Hi everybody, it's Matthew Simon here from Magnet Forensics. I'm a forensic consultant in the Magnet Forensics APAC team, and I want to talk today about remote acquisition of data so you can more rapidly and covertly access data for your investigations. I'm going to talk a little bit about all of this in the context of IP theft. So as mentioned, I'm a forensic consultant at Magnet Forensics. We have quite a lot of forensic experience across the company. My background is from law enforcement in the South Australia Police and resident here now in Singapore. Worked for Interpol for a number of years before moving over here to Magnet Forensics. So today, again, I want to talk about remote acquisition of data and really the workflow that is quite different to maybe what the conventional workflow is when collecting data, which is that physical access to media and actually doing a bit for bit image of that, which is definitely the gold standard for getting all the data. That is the big advantage of that, and from a law enforcement criminal investigation perspective, it is usually what you would want to go for. But there's some disadvantages to that, especially in more corporate type investigations, and that is, well, it requires physical access, which can be difficult. You actually have to go down to a computer or get your hands on a laptop and actually pull the disk out or find some other means of imaging that. And that can be slow, both acquiring access, but the removal and the imaging of the disk as well. And it also creates these very large images. So if you have a terabyte hard drive, you may typically have anywhere from 500 gigabyte image up to a terabyte. And you get more data than may be necessary to achieve the goal that you're trying to achieve. And also, it can be overt. So pulling a hard drive from a computer is more difficult to be covert in those situations. Not impossible, but more difficult. The idea of having more data than necessary is an interesting one, maybe to most people. But what I'm talking about here is that in many cases you may need just a very limited amount of data to be able to progress your investigation to the next step, rather than have everything. So these enormous images. So Magnet Forensics, we have a product called Axiom Cyber that supports remote acquisition of data from Windows computers and from Macs. And it's really designed to allow this very rapid and covert acquisition of data to be able to perform that piece of the process so very quickly, so you can move on with the next part of your investigation. So covert remote collection, our solution, it provides both the ability to get logical files, which we think is typically the workflow that you want to go with, but also full disk collections as well, if you do want that full disk or any devices attached to a target, and memory, both full memory and processors as well, and the ability to collect from Mac, which is a different process to that of Windows. It's logical only, there's no physical disk access, but it does get around the problems with the T2 security chips and the SIP being enabled. And some of the features we've got built into this is automatic reconnection. So if the target drops off the network and comes back on, the remote access will pick up essentially where it left off. And it's quite configurable. And I'm going to dive in a bit deeper and show you this today. So I just wanted to give a bit of an overview of what this remote acquisition looks like. There are several solutions to be able to do this kind of work, and this is the way that Axiom Cyber achieves the goals. You can see on the left there is what would have called a server or a listener. That is the Axiom instance that you'll have that will be listening for connections from a remote agent. And it's the remote agent that's actually going to dial back to the listener and make that connection. So step number one, you can see there is creation of the agent. You can see that the agent actually has the IP address of the workstation that has the Axiom server on it, which in this case is 10.10.10.3. And it also has a port number. You can choose any port you like within the range of user ports, as obviously as long as it's not already being used. And that information will be used again to dial back to that Axiom listener. So steps 2 and 3 there, you can see these can be done in one step, is deploying the agent and executing that agent on the remote target. So you can see that that needs to be pushed over to that target that I've got there. So for instance, 10.10.10.7. And once that has been executed, then the agent will be running on that target. And you also need to start your Axiom instance listening on that same port. Step number 4 there, you'll see the agent is connecting back via TCP. These are secured connections with self-signed certificates at this time, but they are generated on a per installation basis. So quite secure there. So the agent connects back, and at this point, then the server has control of that agent to be able to explore and acquire data from that target. So you can see step number 5 there is a bidirectional step where the Axiom listener can request information, and the target will send that back. That data there in step number 6 is collected into some sort of container. And we've got 2 options for that, which I'll demonstrate in a minute. And then in step number 7, optionally, you are able to have the agent delete itself. You can leave that there as well, optionally, if you want to. So that's the overview of how that works. I'm going to switch now over to Axiom itself. I have Axiom Process here, which, as the name suggests, is the part of the tool that will do all the processing of data. Here with Axiom Cyber, if you're familiar with Axiom but not Axiom Cyber, you will see this remote option here, and that is indeed what is used for the remote acquisition. And this is only included with the cyber version of Axiom. So I'm going to go ahead and come into here. And the first thing you're going to see is a list of agents that have already been created. So the nice thing about the way that this is currently set up is that you only need a limited number of agents. Well, you may only need a limited number of agents. So in this instance, I've created one, and I can use it for any Windows or any Mac in my network that I've got, as long as I'm collecting one at a time. But I've got these 2 existing agents here, but I'm going to go ahead and show you the process of creating a new agent. So I'll click on the Create New Agent. First thing I'm going to need to do is select the operating system, Mac or Windows. I'm going to start with Windows today. I've got a default name here of agent.exe. That may or may not be a covert name. Lots of endpoints have lots of different agents on them these days, so maybe that will allow it to blend in, but if you wanted to, you can change that to absolutely anything you want. So just so it blends in, we'll call it Blender. If you have a mind to, you can also fill in some more of these fields: file description, company, product name, copyright and legal trademarks, so you can put any information in here that you want. Again, that is both so you can be more covert if somebody has some skills to be able to look at executables. Perhaps that will allow it to blend in. In some instances, these fields can also be used for a version of whitelisting. I'm not going to fill any of these in today. I'm just going to leave them as they are. They're completely optional, but I'm going to leave the name there as it is. And then we also have the location of where this is going to be written. So I've got a file path here. For me, it's my D drive, D agents, and a folder name. So just for the sake of this demonstration, I'm going to call that folder Blender as well. Now, this is an important part because this is a step where some people get confused. And this is the IP address or the host name of my own computer. And it's the computer that I'm on now. And you may ask, well, that's not particularly complex. But even on my local computer here, I have a number of different interfaces because I have a VMware installed, for instance. So there's a number of different IP addresses I can actually use here. So, for instance, for me to access my my virtual machine target here, I'm going to need to use the IP address 192.168.3.1, and I'll show you that my target here is on my network at 192.168.3.137. So that's the same port, and I can go ahead here and pick any port that I want. I'm going to pick 54321, just a completely random number, as you can see. The reconnect delay here is how often this agent that I'm about to create is going to attempt to connect back to my listening server, and the disconnect keep alive is how long that the agent will keep running while it's not connected. So if I go ahead and create that agent, you can see there it's been created. And I'm going to show you my D drive here, D agents, and there's my new folder, Blender, and there's my executable there that I've just created. Go ahead and move that away. So now I can use Axiom to go and deploy this onto my target, or if it's already deployed, I can just drop straight into listening mode. If I choose deploy, I'm going to need to put in my the IP address of my target here, a username and password of an administrator on there. So this typically in most workflows would be a domain administrator, which has access to all the computers. But there's other systems of doing this, and also a location on the computer where you want that agent deployed. I'm not going to use this method today. I am going to use a different method, and that is PSExec, simply because I just want to show you the connection stages here. So I'm going to drop in my blender.exe here. So I'm running PSExec. My target here is VM Howard. I just said to you what the IP address of my target was, but in this particular case, I'm going to use the host name. So this is essentially the same thing. The -U switch here is the user, and that's connecting as administrator. And the -C switch here is the file that you're going to push on, and it's going to automatically execute that. So as soon as I hit enter, it is already connecting. It's asking me for the password for that user. I'm going to type in the password. It's now connecting and all going well. Maybe I can't type correctly. Try again, because the second time you type the password, it's always correct. And so you can see here now that this has actually been pushed on and that agent has actually been executed. Now you see this these exceptions being thrown here, and this is happening in the background because Axiom's not actually listening yet. So that's just telling me that the agent is unable to connect. So I'm going to now move into the connection phase. I'm just going to point out here that data compression is turned on. This is a new feature that we have in the tool, and it essentially allows the agent to compress data before sending it back over the wire. The advantage of this is less data being sent over the wire, so it's much quicker. However, the downside is that it takes more resources on the target computer. So you need to weigh those factors up. So I'm going to go into Connect Agent. I'm going to bring up my terminal here again, and you'll see this has now connected. So it's not throwing these exceptions anymore. And you can see here agent connected to 192.168.3.1 on port 54321. And that's exactly what we set. And you can see here now we have computer name VM Howard. That's what's connected. With the user administrator, that same IP address, and that it is connected. Now I can show you this this computer. This is it here, and this is akin to a computer running on a domain. If I log in here, oh, it's just updated. That's nice. Let's just close that. Point being is that you will see that there's nothing obvious running here on this computer, no obvious agents running anywhere, nothing that would make a user suspect that that something was going on there. If I do dive into my C drive, if I'm a little bit tech savvy and want to check if I'm being investigated, then I could go have a look here in the Windows folder and see here this Blender and PS exec. This would be a dead giveaway, but I'm also able to push that to a different location if I want to as well. So I'm now connected to this machine here. I can go ahead and start collecting data. The first thing before I do that, I'm going to point out is the container that I'm going to push all this data to is currently zip. We actually have an option for either zip or AFF4L. AFF4L is a logical container format as well that is superior to any other logical container files that currently exist. The downside of it at the moment is that it's not widely used, so compatibility between tools is still quite low, but we hope that'll grow soon. So if compatibility is an important aspect of your collection, then definitely keep this here as zip. Okay, targeted locations is essentially a list of predefined locations. You can actually add these yourself, and you'll see a couple here I've put here myself. And this makes it easy to simply get a list, to simply go out and collect all the data that you want and not miss anything. So here you can see I definitely want to get the $MFT file. If I wanted to, I can really target certain locations. So if I just wanted items on the desktop here, I could just tick this. But I'm not going to do that because I can select all user folders if I want to. So see users, usernames, that's all files within there. I would very often want to collect all the event logs. I may or may not want to collect a page file. If it's sort of a general IP theft investigation, I maybe wouldn't do that. Definitely have a look in the recycle bin there. Definitely want to grab the registry files. Not going to grab the swap files today. And the web browsing activity is already covered under the user folders. So as soon as I hit the next button, it's going to start collecting that data straight away. So you can see that counting up. It's already collected 100 meg, 120 meg now of the MFT. The nice thing about the targeted locations is that you can select these before the target has even connected back to your listening Axiom instance, so that this will start happening at the moment that agent is connected to you and will start pulling data down. Obviously, we can't do that with files and drives because Axiom doesn't know what the content of the drive is. But once we have that connection, we're able to start exploring the file system and just pulling back anything we want from there. So one thing that I didn't collect, for instance, through the targeted locations is the USN journal $J. So I could come in here and select that file. So this could be a very important source of information. You can see there it's 0 bytes, but of course it's the alternative data stream that we're looking for there. And I've ticked that file, and you can see now that that is waiting to be collected, and that will happen after it goes down the list here. If I wanted to collect anything else, obviously I can do that, and I can continue just to explore the file system, see the dates and times, and see any other devices that are connected here. Same with drives. I have one physical drive connected here, but if there was a USB connected to this particular computer, you would see that listed here as well. And that may be a time when you would want to get a full disk image of something that's a bit smaller. But of course, you could still get a logical of that as well, because again, you would see that if it was plugged in here as D, you would see that drive there as well. And then memory, you will see here a full list of all the processes that are running. You can collect some or all of those, or if you want full memory acquisition, you can go ahead and add that to your list as well. Once that is completed, you will be then able to move on. Axiom will store all that into the selected container file, and then you'll be able to work your way through the processing details and actually process that data as regular computer data. I am going to stop this now because I want to move on. So I'm going to go back and leave all that there for now, and I'm going to show you the process for Mac, which is very similar. I'm not actually going to create a new agent here. You can see that this is quite the same. Select Mac. You can give it a name. Again, you can give it more details, but the process here is exactly the same. Here is one I have prepared earlier for Mac, so I'm going to deploy that, and I am going to use Axiom this time to deploy that agent. Now, there's a bit of a difference between Windows and Mac in this case as well. With Mac, you do need to have the system set up correctly for this to work. So there's a bit of a policy situation likely that would be needed within your organization to ensure that the Mac is set up to be able to have this agent deployed on it. So in this case, I'm going to deploy it onto a Mac that's hardwired into my network here, and it is at 192.168.1.213. I have a username here of old Tony Harrison. Oh. And type in the username and password for this particular agent, and I'm going to just stick it straight in the temp file from the root directory. And have I got that backwards because I've been working on Windows? This time we'll have some success. Yep, so we've deployed the agent here. We've launched the agent. Again, data compression is turned on, so now I'm going to connect to that agent. So it could be up to 10 seconds for this agent to connect because it's retrying every 10 seconds. There we go. This has been connected. You can see that's my Mac Mini there. I'm connected with the username root because that user has root access. The IP address there, and that I'm connected. And then again, this is the same. We have a list of targeted locations. You can add new ones to this as well, and these are, of course, tailored specifically for the Mac as well. Or you're able to go to Files and Folders, see all the drives there. Here is my data volume here. We have this user, Tony Harrison, which we've logged in as. We also have this shady character here, Matt, and another one called Kate. So I can go collect, all of these user profiles if I want to, and do whatever I need to do in the scope of my investigation here. Again, when I hit next, it's going to go start collecting that data just as you saw before. So that's the same. And then the stop and delete agent, once I've completed here, collected all my data and packed it into a zip container in this case. Once I hit stop and delete, that's going to delete that. And if I had actually collected any data, then you would see a new evidence source listed here, and I'll be able to go through all the processing. So of course, I'm not going to spend the time to collect and process data here today, but I would like to just show you and come back to the main point that you're able to get most of the data that you need just through these remote acquisitions. So this is a collection of that same virtual machine there. Someone using that machine suspected of IP theft. And you can see here that just through this remote acquisition, I've got 403,000 artifacts. Many of the artifacts that you would want to view earlier investigation for an IP theft would be down here in operating system. And you can see here, there's my USN journal that I went out of the way to collect. So you can see that's been fully collected and processed. I've got my event logs here. I've got here my user accounts. So there's my target there, Howard Moon, and the user SID. I've got my full USB history here. So I'm still able to piece together the USB history, have a look at the first and last connected times of all the USBs and that kind of thing. Of course, link files as well, crucially important. These are just regular files, but again, you don't need a full disk image to recover all of these. Of course, you won't get any carved link images from an allocated space, but again, the time taken, this is a 5 GB image versus a 40 GB image if I did a physical image here. I've got all my jump lists, my list of installed programs, my operating system information. I specifically elected to get the recycle bin information here as well. So you can see that I've got everything I need to carry out my IP theft investigation. Of course, if I've got file names and hashes that I want to search against, I can do that. And I've got all my documents here. So if I've got some information about what documents might have been accessed, then I can search through all of these. Emails, because I've collected the PSTs that are on there. Any web-related information, again, I've gone out of my way. Has a particular user gone out of their way to use Dropbox to collect information? We can go explore the web history here, and as you can see here that well, there is actually some pretty shady activity here that might have occurred. So this was just a quick overview. I really wanted to focus on the remote acquisition part, but I really wanted to bring that back and really emphasize the point that you're going to get most of the data that you need, or all of the data that you need to carry out your investigations, and probably wrap them up, or at least move on just with this quick and covert means of accessing data. So in wrapping that up, if you have any questions, please feel free to reach out to me. My email address is here. Please connect with me on LinkedIn as well. Very happy to chat about this or any of our other solutions generally. So please don't be a stranger. Thank you very, very much for your time today. Have a great day.